Okay, this is page 148, number 48. It is not a homework problem, but it is one I've determined to be a good one to know how to do. And so I'm going to start out. If you read it, a 3 kilogram block starts from rest at the top of a 30-degree incline. So this is a 30-degree incline. Let's go ahead and write that in there. And accelerates uniformly down the incline, moving 2 meters in 1.5 seconds. So A, find the magnitude of the acceleration of the block. Well, that right there is going to be an old equation that basically says delta x equals v initial times time plus 1/2 a t squared. And it starts from rest, so this whole part goes away. Then we're left with delta x equals 1/2 a t squared. Well, we're wanting to know acceleration, and we know everything. So if we solve this for acceleration, we get 2 delta x over t squared equals a. That's going to be 2 times how far did it move? 2 meters. And how long did it take to do that? 1.50 seconds, and you want to square that whole thing in the denominator. So basically, when you do that, you get 1.77 something, and it rounds to 1.78 meters per second squared. That's my A. Well, the next part's a big jump. It says find the coefficient of friction, of kinetic friction between the block and the incline. Well, we're going to do a quick force diagram. That's mg. And that is 30 newtons, right? And of course we have a different color here. We know that this divides into a y part and an x part. Those are supposed to be straight lines. And we know that the angle here is the same as the angle of the triangle, which is 30 degrees. All right? So how do I find the red part? Well, the red part, I'll just draw a line down here. The red part is found. The hypotenuse is 30, and the red is adjacent to the 30-degree angle. So it would be 30 newtons times cosine of 30 degrees. And when I get 25 point something 98, which is 26 newtons. So that's 26 newtons. The blue part, I'll draw an arrow down here for it, is going to be, the hypotenuse is 30, and it's opposite the 30-degree angle, so it's going to be 30 newtons times sine of 30 degrees, and that's going to equal 15 newtons. So we know the part of friction pulling it downhill, the part of gravity or weight is 15 newtons. And we know that the normal force is going to be equal to that part of gravity pulling it onto the incline, which is going to be equal to this red part, which is 26. Oops. Hold on a minute. Which is 26 newtons. All right? So, and by the way, hopefully y'all understood how I got that. I'm going to switch these two right here, B and C. All right? I'm going to find C first, because really, there might be a tricky way to find coefficient of friction, which you're asking for in B. The B part, we find the coefficient of friction using this equation times the normal force. That's the fun equation. But if you'll notice, if we find it this way, I got to find friction first. Well, friction points which direction? It points up the hill, and I don't know how big it is. All right, that's friction. So what we're going to do is we're going to come down here, and we're going to say the sum of the forces, we're doing B and C together, doing C first, is equal to the net force, which is equal to MA. So, the sum of the forces, well, I'm looking at the horizontal forces here, which is 15 and F. What do I do with 15 and the force of friction? I subtract them. I'm going to always call friction negative. So 15 newtons minus friction, that's the sum of the forces, equals, I don't know a net force, but I do know M, that's 3 kilograms, and I know A. They gave me A, no, I found A, right here, look, I found A. That is A, so therefore A is going to be 1.78 meters per second squared. So all I have to do is solve for friction. And when I do that, and all the negatives divide out, I get 9.66 newtons. All right, that's C. Now I can find B, because the coefficient of friction is the frictional force divided by the normal force. And that's going to be 9.66 newtons divided by 26 newtons. And when I do that, I'm going to get 0.37. And remember, there's no units for that. So there's my answer to B. There's my answer to C. And here's my answer to A. And then the speed of the block after it slid 2 meters, that's going to be, that's D. We know time is 1.5 seconds, so just be V final equals V initial plus A T. V final equals 0 plus 1.78 meters per second squared times 1.50 seconds. 78 times 1.5 gives me 2.67. And if you look in the book's answer, that is right, 2.67 meters per second. So there you go. That's how you do number 48. Good test question. It's going to be very important that you're able to draw these diagrams and be able to interpret them in such a way that you can use Newton's second law, this equation right here, and be able to get different unknowns from that. So